Dear students, let us start Standard 9 ICSE syllabus Chemical Bonding. This is chapter 4. Children, this chapter I am going to divide into two parts. Yes, in the first part we will discuss about electrovalent bond. Yes, electrovalent bond. And in the part 2, that is second part, we will discuss about covalent bond. Yes. Okay, so let us start today's session. Children, in this video, our objective is to cover the following topics: chemical bond, types of bonding, electrovalent bond, electrovalent compound, electrovalency, formation of electrovalent compound, that is, we are going to learn about the formation of NaCl, that is sodium chloride, CaO, that is calcium oxide, and MgCl2, that is magnesium chloride. Okay. Children, before knowing more about chemical bond, okay, let us know first what do we mean by metallic and non-metallic character. Children, metallic character means the tendency of an element to lose its outermost electron. Yes, outer electron. And after losing electron, they are becoming cation. Yes. Similarly, non-metallic character means they will accept the electrons. Yes, they will accept the electrons during chemical reaction, and after accepting the electrons, they are becoming anion. Yes. So now, see, this is the periodic table, right? This is the left hand side of the periodic table and this is the right hand side of the periodic table. In the left hand side, we are having metals, and in the right hand side, we are having non-metals. Yes. So children, this is when you are moving from left to right, then we are saying that we are moving across the period. But when you are moving from top to bottom, then we are moving down the group. Yes. So what happens, children, when you are moving from left to right across the period? What happens to the metallic character? The metallic character decreases. Yes. When you are moving from left to right, what happens to the metallic character? It decreases. Yes. And what happens to the non-metallic character? It increases. Yes. Similarly, when you are moving from top to bottom, that is down the group, what happens to the metallic character? Metallic character will increase. And what happens to the non-metallic character? It will decrease. Okay. So this is all about the metallic and non-metallic character. Yes. Now let us know about chemical bond. Children, if somebody is asking you what do you mean by bond, yes, what do you mean by bond, then what will be your answer? We can define the bond as the action of one sec, children. Yes, okay. Simply a bond can be defined as the action of joining things securely by means of adhesive. Adhesive means sticky substance. Okay, adhesive, heat, or pressure, or by chemical bonds. So bonding can be simply defined as the action of joining things. Yes, the action of joining things. So here we are learning about chemical bond. Yes. So how can you define chemical bond? Chemical bond takes place as a result of combination of atoms of various elements in different ways. But still now we are having many questions in our mind. So what are those questions? Children, here are the questions that we want to know during this session. Yes, why do atoms combine? Why are only certain combinations possible? Why do some atoms combine while others do not? Why do molecules possess definite shapes? Yes, let us try to find the answers of all these questions. Yes, children, we know that what is our universal rule? If you'll see that every object in this world tries to attain stability. Yes, every object in this world tries to attain stability. That means if you are unstable, then definitely you will become or you will feel uncomfortable and you will try to become stable. Okay, that is the universal rule. And what do you mean by stability? Stability in atoms refers to stable electronic configuration. Stability means in case of atoms means we are saying that stable electronic configuration. Okay. All atoms have a tendency to react due to the presence of incomplete valence shell. shell. As we know that if they are not having 8 electrons in their outermost shell, then definitely they are going to take part in the chemical reaction. Here it is given that exception inert gaseous atom. Why? You know children, because they are having 8 electrons in their outermost shell, hence they are not taking part in any chemical reaction. Okay. To bring stability, atoms develop a force of attraction which binds them together to form molecules. So this force is called chemical bond. So how can you define chemical bond, children? To bring stability, atoms develop a force of attraction. Simply we can say that chemical bond is nothing but a force of attraction which binds the atoms together to form a molecule. So it is a force of attraction. Yes. So here is your definition. The force which acts between two or more atoms to hold them together as a stable molecule is called a chemical bond. Now let us learn about the types of chemical bond. Children, we know very well that we are having two types, that is electrovalent bond and covalent bond. Electrovalent bond is formed because of the donating or accepting of the electrons. Because of the donating or accepting of the electrons. Yes or no? Mainly the electrons which are present in the outermost shell. And why this happens? Because in order to attain the stable electronic configuration. But what about covalent bond? Covalent bond is formed by sharing of the electrons. Okay. Now we will know more about this. We will learn about electrovalent bond in this video, but we will learn more about covalent bond in part 2 video. Okay. Children, let us know what do we mean by electrovalent bond. At first, let me tell you, electrovalent bond is also known as ionic bond. Okay, ionic bond, or we can say that the other name of electrovalent bond is ionic bond. Okay, so how can we define electrovalent bond? The chemical bond formed between two atoms by transfer of one or more electrons from the atoms of metallic element to an atom of non-metallic element. Children, we know very well that metallic elements, what are the properties of those metallic elements? Good reducing agent, electropositive, undergoes oxidation reaction, loses electron to form cation. So this electrovalent bond is formed between metallic element and non-metallic element. And as I told you, this bond is formed because of the donating and accepting of electrons. So here metallic element will donate the electrons and non-metallic element will accept the electrons, and hence the electrovalent bond will form. So what are the nature of non-metallic element, children? Good oxidizing agent, electronegative, undergoes reduction. Since they are called good oxidizing agents, so they undergoes reduction and gain electrons to form anion. Yes, so here you can see the diagram that reducing agent, they will undergoes oxidation reaction, and oxidizing agent, they will, this is your oxidizing agent, so they will undergo which reaction, children? They will undergo reduction reaction. Okay, now let us learn about electrovalent compound. Okay, electrovalent compound. What do you mean by electrovalent compound? Electrovalent compounds are the chemical compound formed as a result of transfer of one or more electrons from the atom of metallic element to an atom of non-metallic element. Okay, so whenever transfer of one or more electron takes place between metallic element to an atom of a non-metallic element, of course electrovalent bond is formed, and we are getting what type of compound, children? Electrovalent compound. So what are the general characteristics of electrovalent compounds or ionic compounds? As we know very well that the other name of electrovalent compounds is ionic compounds. So what are the general characteristics? First one, ionic compounds are usually solid in nature. Why, children? Because they are having strong electrostatic force of attraction between the particles. Yes. Second, ionic compounds have high melting and boiling point. Why? Because as I just now I told you, they are having strong electrostatic force of attraction, hence they are having high melting and high boiling points. Third one, ionic compounds are soluble in polar solvents, but they are insoluble in non-polar solvents. Ionic compounds are good conductor in molten state or in aqueous state. Children, in solid state they are bad conductor, because in solid state, since the particles are having strong force of attraction, hence the conductivity becomes very weak or very less. But in case of molten state or aqueous state, the force of attraction between the particle is usually very weak, yes, as compared to the solid state. Hence what happened, the conductivity becomes possible, or we can say that in that case ionic compounds are behaving as good conductors. Okay, ionic compounds has crystal structure. Okay, now electrovalency. We have learned about electrovalent bond, electrovalent compound. Now what do you mean by electrovalency? Electrovalency is established by the actual transference of one or more valence electron. Yes, mainly what happens, children, valence electron, that means electrons are lost from or gained from whatever reaction takes place. It happens in the outermost shell only. Yes, electrons are lost from the outermost shell of the atom. Yes or no? So mainly it is written that electrovalency is established by the actual transference of one or more valence electrons from a metallic atom to a non-metallic atom. In case of metallic atom, what happens, children? The electrons from the outermost shell is donated, and in case of non-metallic atom, the electron is accepted. Yes, and whatever reaction takes place, it takes place in the outermost shell only. Yes, takes place in the outermost shell. So what are the electrons present in the outermost cell? They are responsible for the chemical reaction. They are mainly responsible for the chemical reaction which is taking place between two atoms. Yes, so that each of the why this chemical reaction takes place, children, we know that very well. This reaction takes place in order to attain the stable electronic configuration. Okay, so the number of electrons donated or accepted by the valence shell of an atom of an element to achieve stable electronic configuration is called electrovalency. So what do you mean by electrovalency? Electrovalency can be defined as simply the number of electrons donated or accepted by the valence shell of an atom in order to attain the stable electronic configuration. So let us here you can see the example. One sec, children. Yes, so here you can see the example. Here magnesium is having 2 electrons in the outermost shell. Yes, so here what happens, children? You can see very clearly that in order to attain the stable electronic configuration, magnesium has to donate 2 electrons. Yes, and oxygen, in order to attain the stable electronic configuration, oxygen has to accept 2 electrons. Yes, and after doing this, they will attain the stability, that means stable electronic configuration, and electrovalent bond will form between those 2 atoms. Yes or no? So hence they will form the electrovalent compound. Yes, so if I will ask you what is the electrovalency of magnesium, so what will be your answer? Here in this case, 2 electrons are donated. Yes, 2 electrons from the valence shell of magnesium atom was donated. Yes or not? In order to attain the stable electronic configuration. So here electrovalency will be +2. Okay, and here in case of oxygen, the electrovalency will be -2. Minus shows that electrons were accepted, whereas plus shows that electrons were donated. But children, whenever we are writing valency, or whenever valency is asked in the question, always it is means you need to write in whole number. You should not mention plus or minus sign. Okay, here I told you in terms of plus and minus in order to make you understand. Otherwise valency is always written in whole number, right? Now, so electrovalency explains the formation of ionic compound. Okay, so by knowing the electrovalency, you will able to know the formation of ionic compound. Again, I am telling you, children, ionic compound is nothing but the other name of electrovalent compound. Okay, so now let us learn the formation of different electrovalent compounds. Formation of electrovalent compound. Now let us learn the formation of sodium chloride. Here you can see sodium atom. Okay, children, what is the atomic number of sodium? It is 11. Okay, now how can we write the electronic configuration of sodium? It is 281. That means sodium needs to lose one electron in order to attain the stable electronic configuration. After losing one electron, it will become sodium ion, that is Na+. Plus means cation. Cations are mainly formed by losing electrons. And after losing one electron, the electronic configuration will be 28. Okay. Similarly, here you see, children, this is chlorine atom. The atomic number is 17. So electronic configuration is 287. Okay, that means in order to attain the stable electronic configuration, chlorine needs one electron. Okay, chlorine needs one electron. After getting one electron, the configuration or the nearest noble gas configuration will be 288. Okay, that means it has 8 electrons in the outermost shell and it will attain the stable gas configuration. Okay, or we can say that it will become stable. So here sodium is going to lose one electron and chlorine is going to accept one electron. Okay, so let us learn about the orbital structure first. Okay, we are going to learn here two structures. One is your orbital structure, another one is your electron dot structure. So we'll learn first the orbital structure. Here is the sodium atom. So let us draw the orbital structure of sodium as we have drawn earlier. 2, 8, 2, 8 and then 1. That means one electron in the outermost shell. Similarly, chlorine 2, 8 and 7. 2, 8 and 7. That means 7 in the outermost shell. 7 in the outermost shell. So now what I told you, children, in the when I was explaining you about the sodium atom and chlorine atom, sodium atom is going to lose one electron, whereas chlorine atom is going to accept one electron in order to attain the stable gas configuration. So here what we'll see that one electron from sodium will get transferred to the chlorine. Okay, so after getting transferred, it will, as I told you, it will form sodium ion. Okay, so the electronic configuration will be like this. This is your nucleus, this is your 2 and here 8 electron in the outermost shell, because that one electron which was present in the outermost shell was transferred to chlorine. Okay, and in this case it forms anion, that means chlorine ion, that is anion. How anions are formed, children? By gaining electrons. Okay, so here after getting electron, it is now chlorine is having 8 electrons in the outermost shell. Now let us draw the orbital structure of chlorine after getting one electron, that is 2, 8, 8. Okay. So now you see, children, in both the cases 8 electrons are present and hence they are stable now. So they are forming the electrovalent compound, that is sodium chloride. Okay, sodium chloride. Here this is sodium chloride. Okay, now let us learn the electron dot structure of sodium chloride. Children, I'll tell you one thing. In the orbital structure, you are showing all the shells along with the electrons which are present in the different shells. But in case of electron dot structure, you need to show only the electrons which are present in the outermost shell. Okay, now let us draw the electron dot structure. In case of electron dot structure, you are representing the electrons in the form of dot. Here no need to draw the orbits or shells. Okay, so this is your sodium. How many electrons are present in the outermost shell of sodium, children? 1. So this is 1 electron, and this is your chlorine. How many electrons are present in the outermost shell of chlorine, children? 7. So 1, 2, 3, 4, 5, 6 and this 7. So now, as I told you, 1 electron will get transferred to chlorine. So after this we are going to get electrovalent compound, that is NaCl. So sodium will get the sodium ion and chlorine ion, sodium Na+, that means it will form cation by losing 1 electron, and here chlorine Cl minus. Why? Because it's getting one electron. Okay, it's getting one electron from sodium. So like this we are getting NaCl. Okay, NaCl. So this is the electron dot structure of NaCl. Now let us learn about calcium oxide. That means the formation of calcium oxide. First we'll learn about calcium atom, then about oxygen atom. Children, you see here calcium atom. Tell me children, what is the atomic number of calcium? It is 20. Okay, atomic number of calcium is 20. Now, how can we write the electronic configuration of calcium atom? It can be written as 2, 8, 8, 2. Children, we cannot write 2, 8, 10. As I told you, in the outermost shell, maximum number of electron that can accommodate is 8, not more than 8. Okay, so the electronic configuration is 2, 8, 8, 2. Okay, so let us draw the orbital structure. As I told you, we need to draw the nucleus first, then 2, then 8 electrons, and after that again 8 electrons, 1, 2, 3, 4. Okay, 5, 6, 7, 8, and then at last 2 electrons. That means 2 electrons in the outermost shell. 2 electrons in the outermost shell. Similarly, oxygen atom. Children, tell me what is the atomic number of oxygen? It is 8. That means the electronic configuration is 2, 6. Okay, so let us draw the orbital structure. 2 and here 6. 1, 2, 3, 4, 5, 6. Okay, so here you can see clearly that in order to attain the stable gas configuration, calcium atom needs to lose 2 electrons. Okay, and oxygen atom needs to accept 2 electrons, so that in the outermost shell both will have 8 electrons. Okay, so now let us learn the orbital structure of calcium oxide. Okay, orbital structure, how the formation of calcium oxide takes place. Okay, after that we'll read about the electron dot structure. Okay, now let us draw the calcium atom first, as we have drawn earlier. First is your nucleus, then 2, 8, then again 8, 1, 2, 3, 4, 5, 6, 7, 8, and at last 2. Okay, 1, 2. Okay, here in case of oxygen, 2, 1, 2, 3, 4, 5, 6. Okay, done. Now children, you see here, in order to attain the stable gas configuration, or in order to become stable, as I told you, calcium atom needs to lose 2 electrons, and so oxygen atom needs to accept 2 electrons. So here they are going to lose 2 electrons. For example, they means calcium. Okay, so here 1 electron and this 1 electron. Both the electrons which were present in the outermost shell were transferred to oxygen atom. Okay, after this, what happens? Calcium ion is formed, and oxygen ion. Both calcium ion and oxygen ion we are getting. Calcium ion will form in the form of cation. Okay, cation. Why children? Because they are losing electron. And oxygen will form anion. Why? Because they are gaining electron. Okay, so here you see, after losing electrons, the calcium ion will be like this: 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and here in the valence electron 8. That means they are having 8 electrons in the valence shell and they are stable. Similarly here also 1, 2, and 6 was there, but after that they got 2 electrons. That means 8 electrons. Okay, why I have written here 2 plus children? Because they are losing 2 electrons, so 2 plus, and they are gaining 2 electrons. That's why 2 minus. This is cation and this is anion. Okay, now let us draw the electron dot diagram or electron dot structure of calcium oxide. Okay, electron dot structure of calcium oxide. Okay, now here what we are going to do is, as I told you, we need to show the electrons which are present in the outermost shell of calcium atom and oxygen atom. See children, calcium, how many electrons are present? 2. Similarly, in oxygen, how many atoms are present? 6. Yes, in the outermost shell, okay, in the outermost shell. Now as I told you, calcium is going to lose 2 electrons in order to attain the stable gas, so it will be like this. Don't forget to show the arrow mark, okay. So means electron transfer should be shown in the form of arrows, okay. So now you see, after losing 2 electrons, calcium will become 2 plus, that means ion, and we will get oxygen 1 2 3 4 5 6 7 8, and it will become 2 minus, because they are getting 2 electrons, that's why 2 minus. They are losing 2 electrons, that means 2 plus. So they will form CaO, that is calcium oxide. Okay, here the electronic configuration is 2882 and here it is 26, but after this, after losing or gaining electron, they will become calcium will become 288 and here oxygen will become 28. Okay, this is the electronic configuration. Okay, so like this we can draw the electron dot diagram of calcium oxide. Now let us learn the formation of electrovalent compound MgCl2. Okay, so first, as we know, we will do the atomic orbit structure. So this is your magnesium atom, right? Magnesium atom. Children, what is the atomic number of magnesium? 12. So what should be the electronic configuration, children? It should be 282. Okay, so in order to attain the stable gas configuration, okay, so what magnesium needs to do? Magnesium has to lose 2 electrons, right? Magnesium has to lose 2 electrons. After losing 2 electrons, what will happen, children? The magnesium will become, it will be converted into magnesium ion. After losing 2 electrons, it will be converted into magnesium ion, that is cation. Why, children? Because cations are formed due to loss of electrons. So after losing 2 electrons, it will become Mg2 plus, right? So here let us draw the orbital structure of magnesium. 282, that means this is your nucleus, as I told. So this is 2 and this is 8. 1 2 3 4 5 6 7 8 and 2 1 2. Okay, now let us know about chlorine. Chlorine, what is the atomic number, children? 17. So what should be the electronic configuration? It should be 287. That means it has 7 electrons in the outermost shell. In order to attain the noble gas configuration, it needs 1 electron, right? So that it will become 8 and it can attain the stability, right? So let us draw the orbital structure of chlorine atom. So as you know, this is the nucleus. Then in the K shell we are having 2 electrons. In the L shell we are having 8 electrons, right? 8 electrons. And in the outer shell, that is M, we are having 7. 1 2 3 4 5 6 7, right? So this is all about chlorine atom. So now let us draw the atomic orbit structure of MgCl2. Okay, so as we know, let us first fill up this one. This is your this you will see before combination and this you will get after combination. Okay, so here we are getting the formation, this side we are getting the formation of MgCl2. Okay, so this is your chlorine. Okay, so chlorine 287, that means this is 2, this is 8 and this is 7. 1 2 3 4 5 6 7. Similarly here also 287, this is 2, this is 8, okay, and this is 7. Okay, children, I am keeping 1 electron this side so that you will able to know how the electron is transferred from Mg and chlorine is getting that electron. Okay, for showing it will become easy. Okay, otherwise this chlorine atom you can both the chlorine atoms you can show here in one side also, no problem in that. Okay, so here in case of magnesium 282, that means this is 2, this is 8, okay, and this is 2, this side and this side. Okay, so this is all about the orbital structure of the chlorine and magnesium atom. Now you know very well that, as I told you, magnesium atom has to lose 2 electrons, right? So 1 electron given to this chlorine, this electron given to this chlorine atom. Okay, so now after giving the or after losing the electrons and after gaining the electrons, the magnesium and chlorine, I'll tell you the orbital structure of magnesium ion and chlorine ion here. Okay, so this is your chlorine, right? So chlorine means they are getting one electron. So here 2, okay, then 8, okay, and then 8. That means they are having 8 electrons in the outermost shell and they got stable electronic or stable gas configuration. Here in case of magnesium they lost 2 electrons, so 2, 8 only. Okay, and here it will become 2 and then 8 and then 8. Okay, 2, 8 and 8. Okay, so this is all about, see children, here it is written that after getting one electron, chlorine atom will become, it will converted into ion. You can see here minus sign. What does it mean? It means it's getting one electron, okay, or it's gaining one electron. So the electronic configuration is 2, 8, 8. Here magnesium is losing 2 electrons, that's why 2, 8, and here again 2, 8, 8. So here you can see that we have written here 2 plus. Why children? Because magnesium magnesium needs to lose 2 electrons in order to attain the stable gas configuration. Okay, so now let us draw the orbital structure. Now let us draw the electron dot structure of MgCl2. Electron dot structure. Children, as I told you, in case of electron dot structure, you need to show the electrons which are present in the outermost shell only. Okay, so this is your Mg. Okay, so Mg, how many electrons are present in the outermost shell? 2 electrons. Okay, now this is chlorine. As you know that we are taking 2 chlorine atoms. So this is chlorine. How many electrons are present in the outermost shell of chlorine, children? 7 are present. 1, 2, 3, 4, 5, 6, 7. Here also you see 1, 2, 3, 4, 5, 6, 7. Okay, so now what will happen? You know very well that one electron will be transferred here and again one electron will be given to chlorine atom. Okay, so after giving, magnesium will be converted to cation and chlorine will be converted to anion, because you know very well that cations are formed by losing electrons and anions are formed by gaining electrons. So here it will become Mg2 plus. Why 2 plus, children? Because magnesium lost 2 electrons in order to gain stable gas configuration. Okay, and here chlorine, as you know we are taking 2 chlorine and so I wrote 2 here, and after that you need to show the electrons here. Why, children? Because after gaining electrons, it is now chlorine, each chlorine atom is each chlorine ion is having 8 electrons, right? So here you see, here in case of magnesium no need to show because in the outermost shell 2 electrons were there and that was given to chlorine atom, right? But here after gaining you need to show in case of chlorine. Okay, so this is your chlorine. So we are writing 1 minus here, 1 minus, because we are taking 2 and here we are showing the means what happens to individual chlorine atom. Okay, this shows that we are taking 2. Okay, so this is all about. Then what we are getting? We are getting MgCl2. Okay, we are getting MgCl2. So this is all about your electron dot structure of MgCl2, that is magnesium chloride. Okay, magnesium chloride. Okay, so like this we can draw the atomic orbit structure and electron dot structure of magnesium chloride. Okay.